Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a problem called extract digits in number using recursion. Okay, what is meant by extract digits? See here, if I give n is equal to 1432, I want to print in two ways. The one way is 1432 and another way is 2341. So you want to print this both two ways. Okay, this individual question, this is individual question. But two are similar, right? That's why I just combine these two. Now, how to use recursion in this problem? Fine. What are the two parts in recursion? They are base case and another one is part or body of recursion. Fine. So what is the base case? Okay, before going into this problem, how can we extract? If you don't know how to extract the element, just move on to the playlist called basics and check out the videos like extract the digits using while loop or individually. Then come back to this video. I will give those playlists in my description. Fine. So how to extract digit? I can say if I want to extract this 2, I will use mod 10 and then I will do divided by 3, right? So that's what extraction means. Fine. So I will do what? First I will take 10 n mod 10 so that I can get the remainder. Then I will do what? N divided by 10 so that I can go to the next part. First I will take this as my remainder. Then if I do n divided by 10, then I will take this 3 as my n value. Then I will do a mod 10. Then I will do a mod 10. Then I will do a mod 10 so that 2, 3, 4, 1 will be get printed. So first we can see this how to print this. Okay, fine. Okay, what is the base case? If I reach at 0, if I reach 0, then I should stop there, right? So I can say if n is equal to 0, then I should stop there. I should stop. Fine. So what is a body? What is a body? Fine. So I can say the body is I want to take the remainder. I want to take remainder. After taking, I want to print that remainder. Yes, then I have to call. I have to call the function. Like how can I call the function? Just f of n divided by 10. I want to pass n divided by 10 to the function call, right? So that I can first I will take this 1432, then I will send 143, then I will send 14, then I will send 1. Now understand? Now understand? Okay. Let us take example and we can see by using a stack, let us stack. Okay, just see here. This is what the function I have wrote above, right? This is what a function I have wrote above. Now just observe this is what f of 1. What is the value? 1432. 1432. Yes, this is the first recursion. Sorry, this is the first initial function, right? Now when I am doing f of n divided by 10, I will I am going to send what is the value? 143, right? 143, and in this rem, what will be stored? 2 will be stored. Yes, and then again I will call another recursion. Yes. Now what is this function? This function name? It is f of 143. Yes. Now what is stored in rem? Rem is stored as 3. Then what is stored in f? F is stored as, sorry, f will pass 1 4. Again a recursion call will be created. Fine. Now again f of 1 4. This is your f of 1 4. Now what is in rem? Rem is 4, and what will be passed? 1 is passed. 1 is passed again. So another recursion call will be created. Yes. What is the name of this recursion call? It is f of 1. Name means just the representation. This is the n, right? F of n. Like this we are representing in each and every function call. Okay, for our understanding purpose, this is what the internal working, right? And then here, what is rem? Rem is stored as 1. What is in f of n divided by 10? It is 0. 0. So another time it will be recursion call. So let me write here. So another time recursion is called. Yes, let me take like this. Fine. Now it is what? F of 0. Now if num is equal to 0, yes, up to this number is not equal to 0. That's why we are going on. But now we have got a end point. End point. So we want to return what? Just return null, so that it goes again here. It will goes again here. Now what should I print at first? At first, just take for example, in this 1432, I want to print first 2, okay, then I have to print 3, then I have to print 4, then I have to print 1. This is my first method, okay. So how can I print 2 first, then 3, then 4, then 1? Okay, just simple. Fine. Just see here. First of all, we are going to this control flow, like this in every function, right? We are going like this. Yes. So where should I put a print statement so that 2 will be printed first? I want to put print here. Print rem. So what should my answer? If I put print rem, then this 2 is printed at first. Then only a recursion call will be called. So I have to put rem here. I have to print rem here. Print rem and also print rem. Now you are clear, right? Why we are printing rem before the function call? Because we want to print 2 first. So inside this rem, first is just 2. So print it, then call. Okay. So this is how we want to do if the output is 2 3 4 1. Okay, fine. If the output is 1 4 3 2, then what should I do? What should I do? Just print here. Just print here. Why we are printing here? After completing this base case, it comes here, right? Here. Now after this, if I print this, one gets first printed first. Then only after completing this function call will execute it successfully. Then it comes to here. Now this will be executed. Again, after executing this, there are no other function call. So the control flow comes here. Again, if I have any other values or any other statement below this, it will be executed, right? Recursion is not like if we go and call a function, that's it. It's like go call a function, then come back, then execute the rest of the program. Okay, it will execute this rest of the program. Then only it will what? Return. Again, execute the program. Fine. So by this way, we can print 1432. Fine. Now do you understand when to use a print statement above the function call and when to use the print statement below the function call? It is more important, okay? Many of them things like, if once this function call is get executed like this, then it won't execute below lines. It won't execute below lines. It is only possible if a return statement is here. If return statement is here, this is the case. It goes, then comes, then it will return this value. If this is not so, then it will execute the rest of the part of the program. Keep on the mind. Okay, fine. Now let's see the program. See here, def extract of num, then num is equal to n. If num is equal to n, it is a base case. Just return. Go back. Now if I want to print first, that means if I want to print at the 2 3, that like for this example, let me say, for this example, if I want to print 4 3 2 1, then I have to do this print statement. Else if I want to print like 1 2 3 4, then I have to go with this print statement. Fine. I clearly explained that logic, right? Now after that, I am going to call the function. Fine. Now if I execute like this by commenting this print statement, it will be like 1 2 3 4. Now if I comment this and uncomment this, the print statement will be like 4 3 2 1. It prints like 4 3 2 1 because first it prints, then only call the function. Fine. So that's why we are just printing 4 3 2 1. But in this print statement, after calling the function, it will print. That means the last called function will be printed first. That's all, right? So what is the time complexity for this program? The time constant is what? N log of n base 10, right? Because we are dividing by 10 consistently. So what is the time constant? Let me write here. What's the time constant? It is O of log n base 10, right? Okay, what is the space constant? I can say space constant is also O of log n base 10. Why? Because we have already we have studied that recursion will create a recursion stack or internal stack. Because of this, a space constant is what? O of n log n. Sorry, O of log n base 10, right? So this is the important note. Many of them forget that using the stack will don't occupies any space, but space constant is like this. Fine. So this is the basic for stack. Now we are going to see about sum of digits in a number using recursion. Okay. Fine. Till now we have seen how to extract the digits, how to count the digits. Now we are going to see about sum of digits in a number. Try by yourself, as you know how to extract in two methods. You can implement this in two methods, like already I have told you, right? By using static and global, and also by using direct methods by breaking down into problems. You can do in two methods. Just try out. If you don't know, just watch this video. Okay, see, first of all, we want to count the sum of the digits, right? First you have to know how to count, sorry, how to take the sum of the digits, right? Let me take 1 4 3 2. Okay, what is the sum? It is 1 plus 4 plus 3 plus 2. What is the answer? It is 10. You have to return 10, right? So how can we do this? Just listen to me. We know how to extract a single element, single element, right? We first extract this 2, then we extract this 3, then we extract this 4, then we extract this 1, right? And take the sum of it. Simple, right? It's simple. When we divide, when we mod by 10, we get the ones place. Okay, now add this ones place, add ones place. After adding this ones place, just divide by 10, so that we will get the remaining part. Yes, so these are the three methods we want to follow, right? Now we have clear vision how to take sum of digits. Now how to implement this in recursion? Okay, fine. What are the parameters we need first? First of all, what are the parameters we need? Okay, we need a function. Okay, and what should that function contains? That function should contains the number. This number, this 1432. That's like the number, and also it should contain a running sum, a sum variable to take the count of this. First, we will take the count of this 2. Then 2 plus 3, 5. Then 5 plus 4, it is 9. Then 9 plus 1, it is 10. Like that. Okay, now we have framed. Now, what is the base case? What's the base case? I can say the base case is at last, while we are continuously dividing this by this 10, at last it will goes to 0. So that's my base case, right? That's my base case. So base case is 0. Absolutely. So if n is equal to 0, then what should I do? I should take that into our consideration. Yes. So what we'll do? We will take a result as static or global in Python, and we will set that current sum into that result, and we will return it. Right. So this is my endpoint, or this is my base case, right? Now at last, what is my body? I can say my body of this function is, we want to pass uh, two variables, what? N and sum. And what should we do this n? We want to continuously divide this n. What should we do this sum? We want to take that ones place and add, right? So f of n divided by 10. This double division is just floor division. Okay, it gives the integer value for Python. And if you are using C, C++ or Java, just use the slash. Okay, it's your wish. Now sum plus n mod 10. This is what we have to do, right? We want to take that one place and add it with the sum. Initially sum will start with what? Initially sum will start with what? 1432, and sum is 0. Finish. We have written all the parts. Now it's time to what? Code it up and see the dry run, right? Let me take, first of all, take this. This is what? F of 1432, 0. Yes, initially. Now what is this place? This place will be refilled like, let me take another color for better understanding. This place will be refilled with 1 4 3. Yes, and then this will be replaced as comma, comma. Okay, now this will be replaced as what? Sum will be what? 2, sorry 0, and this will be 2 because n is already what? 1 4 3 2. While we are modding by 10, it will be 2, right? So 2. Yes, then it will call another recursion call. So let me take this. Yes. Now, what is the recursion call? It is f of 1 4 3 comma 1, sorry, comma 2, right? Again, if we are going like this, n divided by 10 will be what? It will be 14, and then here comma, and then here, what is sum? Sum is 2, 2 plus n mod 10. What is n mod 10? It is again 3, so 3, right? Again, another function call. What is the function call name? Let me paste here. Perfect. Now, what is the function call name? It is f of 1 4 comma 5, right? And whether it is 0, n is 0, no, right? Till now I am checking the base case, but that didn't satisfy the condition. That's why I haven't set this base case. Okay, so whether 14 is equal to 0, no. So directly comes here. 14 divided by 10 is 1, and what is sum? Sum is what? 5. 5 plus 4, it is 9. 9. Okay. Now, what is my recursion call now? Now, my recursion call is 1 comma 9, right? Let me write here f of 1 comma 9. So, whether 1 is equal to 0? No. 1 divided by 10, it is 0. Here, comma. Now, sum is what? 9. 9 plus 1, it is 10. Okay. Another recursion call. What is my recursion call now? Now, my recursion call comes to the end. But how it comes to the end? See here, 0 comma 10. So, 0 is what? My base case. When n is equal to 0, my base case is attained. So, what is my base case? Result is equal to sum. So, result is initially kept as 0. Now, it is strike out and kept as what? 10. So, this is the important point. This is the important point. Or else we also, instead of doing this, we can also print what? Sum. We can do either methods. Okay, either methods, but if we want to store it in a variable, then we want to use this method. If we want to just print, we can use this method. Okay, then return. Fine. Now this return statement will go where? Here. Now whether there is any line of code here? No. So this function will return where? Here. This function will return here, and whether below this function call there is any line? No, because we haven't used any return statement here. If we use return statement, it directly moves, but we don't use any return statement, so it moves to the down part, and there is no code. Again, it also moves here. There is no down code, and again it also moves here. Again, there is no down code. So it goes to the function call. So what is my function call? It is f of 1432, 0, and it will return what? None. This function call will return what? None. So what is my answer? It is 10 when we are printing, or it will be stored in result. Fine. So this is the first method. We just keep a static in C, C++ or Java. Okay. In Python, we will keep as global. Fine. Can you understand now? Now we can see the second approach. What is second approach? I have already told you, right? The second approach is breaking points. Breaking points. See here, 1 4 3 2 can be written as what? Can be written as 2 plus f of, let me take this as a function, f of 1 4 3. Yes, again this can be written as 2 plus 3 plus f of 1 4. Again it can be written as 2 plus 3 plus 4 plus f of 1. Again it can be written as 2 plus 3 plus 4 plus, and then 1 plus f of 0. Yes. While solving this, it will become what? 0. F of 0 is 0, right? This f of 0 is 0. Now 2 plus 3 plus 4 plus 1 plus 0, which is equal to what? 10. So 10 is my output. I can also do like this, right? What does it mean? It is mean like if n is equal to 0, then don't worry. Just what? Return 0. Then what we should do? We should return 0. Else we want to return what? We want to return that current numbers ones place, the current numbers ones place plus the remaining part I have to move the remaining part, so divided by 10. Okay, and what is the function called? F of 1432. And while we are printing this function call, or we can take the result variable, and this function call will be returned. In above scenario it is none, but here it will return the value. Fine. Okay, let us take time to consider time complexity and space complexity. What is the time complexity? Same, O of log n base 10, and the space complexity is also O of log n base 10. And why? Because we have stack space. The stack is created, right? The box. The stack is created. Here also the stack is created, right? See here, first of all, it is what? 2 plus this. And then this can be written as what? 3 plus this. See this. See this. It won't goes like this. See this carefully. This can be written as what? 2 plus f of 1432. And this can be written as what? Like this. Fine. Again, this individual function 14 can be written as what? 4 plus f of 1. And this individual function, if we take any other color, this function can be written as what? 1 plus f of 0. Now this f of 0 is written as what? 0. Now can you understand how it is returning? Yes, like that we have seen that factorial, right? Like that it will be written. Fine. Can you understand now? Yes. So let's see the code so that it will be more clear. See here, sum of digit, then global result. Now num is equal to 0. If it is equal to 0, just take it to the result variable. There I have given sum, here I have given add. That's it. Okay. Now return. Else what should I do? I should make a call like n divided by 10, so that ones place will be cancelled out, and add plus nums of n mod 10, so that it goes like removing the last it goes like removing that last digit, that means that one place, and just adding it up with the add variable, right? Now result is equal to 0. Initially I will take the result as 0, then I will pass that I will call that function, then I will print the result. Let me run it. 8, because see here 1034. Fine. Now let me comment this, and it's time to see the second approach. See here, this is the second approach. If num is equal to 0, then return 0, right? Else what should we do? We should take that last position, that is a ones position, and we should add it with the what? The simplified problem. What is the simplified problem? Removing that ones place and just move on. If we are finding a value for 1432, then 2 plus f of 143. Just simplifying that problem and returning it. Just return, right? Then I am printing this. Fine. This is the second method. You have to know this both the method. Okay, fine. Now it's time to go for the next problem. Now see this question. Count zeros in a number using recursion. Okay, we want to count zeros, but how can we count zeros? Till now we have seen like how to take or extract each and every digits, right? When we are extracting each and every digits, we want to check whether it is equal to 0. Then we want to increment the result. That's it, right? Right. Okay. Then just take for example 10302. Just take. Now first of all I will take what? Mod 10. Mod 10 means I will extract this ones place, right? Whether this ones place is 0, no. So don't do anything, just go like this, just by what? Dividing by 10. Each time we will divide by 10. This is what? Floor division. In Python if we want a integer value, on division we will use this floor division. If you are using C plus Java, just use slash. That's it. Now again we are checking the last unit digit is 0 or 1. Sorry, 0 or anything. It is 0. So we want to do what? Plus 1. And again divided by 10. Now 103. Now again whether it is 0, no. Just divided by 10. So 10. Now it is 0, right? So plus 1 and divided by 10. So now what is the value? It is 1. No, it is one's place is not 0. So again divided by 10, it is 0. The whole term is 0. It's not just 0, the whole term is 0. So we want to stop here. So stop here. So what is my answer? Here also 1, here also 1. So combining this 2, it will be 2. Understand? Yes. Now for this question I will solve by using the second approach. That is, we don't want to use the static variables, or we don't want to use the global variables. I just use the normal method, like dividing the main problem into sub problems, right? Okay. So first is, what is a recursion relation? Fine. We are just taking a number and constantly dividing by 10, and whether the unit place is 1, we want to return 1. Otherwise, we want to return what? 0. That's it, right? Just for example, if I have 103, then what should I return? I should return 0 plus f of 10. If it is f of 103, I want to return 0 plus f of 10. Why? Because this is not 0, right? Unit place is not 0. Then I absolutely what? Do nothing and f of 10, right? If it is f of like 100, what should I do? I should do 1 plus f of what? 10, right? Right? So what should I do? I want to take only one variable, right? So what is my recursion relation? It is f of n alone, right? Now again, what is second method? Second step, it is base case. What is my base case? If the number becomes 0, just don't do anything. Just I want to return what? 0. Because if it is 0, there is no way to go beyond that, right? So just return 0. Fine. Now what is a part? What is a part? That is body. What is the body of the recursion? If the unit place, what is the unit place? N mod 10. If you do mod 10, it will be the unit place will be extracted, which is equal to 0. Then what should I do? I should do what? 1 plus f of. So I want to return what? 1 plus f of n divided by 10. Otherwise, what should I return? If this is not case, then return 0 plus f of n divided by 10. Which can be, this can be also written as what? Just f of f divided by 10. Instead of using the 0, we can use like this. Fine. So this relation, this body is so much important. So much important. Because these are the things we will use while using the what? Backtracking approach, and in DP. In DP also, we will write this kind of approaches. Like when we are using a combination sum, and when we are using some thing like permutation, in those stuff we will use like a condition. Then we will pick or not pick. We just use two ways, like pick or not pick, like that. It will go to the trees and etc. But we don't want those things. But still, just see this. This is the base for that approaches. Okay, so don't distract. Just listen to me carefully. Okay. See here. Let me take f of 1030. Let me take. So this is my whole program, right? This is my whole program. Now, see here, whether n mod 10 is equal to 0, whether it is 0, yes. First of all, 1030 is 0, no. So this base case will not be executed. Now, whether n mod 10 is equal to 0, yes. This is what? 0, right? So we will return what? 1 plus f of n divided by 10. So it will be called. Now, what is the value of this? Let me paste here and then I will discuss that. Fine. What is the value? Value is, I can say 1030 can be written as 103 when we are dividing by 10. Fine. Now, what is this? F of 103. Right? Now, again, what will be the answer? N is not equal to 0. Now, come here. N mod 10. N mod 10 is 3, right? 3. Whether 3 is equal to 0? No. No. So, what should I do? What should I do? This if part will not be executed comes here, and n divided by 10. What is n divided by 10? It is 10. Again, this will be called. This will be called. Can you understand now how to call, right? Again, yes. Now what is the function? It is f of 10, right? Now whether 10 is equal to 0? No. Whether n mod 10, n mod 10 is 0, right? 0 is equal to 0? Yes. Yes. So 1 plus f of n divided by 10 means it is what? 1. So now f of 1. What's the, let me paste here. Yes. Whether 1 is equal to 0? No. Whether 1 mod 10 is equal to 0? That is 1 is equal to 0? No, no, no. So come here. F of 1 divided by 10. 1 divided by 10 means it is what? 0. So we are calling for what? F of 0. F of 0. Again, this is the stopping point. But why it is a stopping point? Because our base case is satisfied. But how our base case is satisfied? Because base case is n, right? N is 0, 0, right? It is also 0. So it is satisfied and we are returning what? 0. So after returning, it don't go. If we are returning, it don't goes to these parts. Okay, it directly goes back to the called part, and call part will be what? 0. Call part will be 0. Now it will return what? This f of 1 will return what? 0. This f of 1 is returning what? 0. Now go here. This f of 1 is returning what? 0. Now 1 plus 0 is 1, right? And it will return here itself. It will return here itself because we are using what? Return keyword. If we don't use this return, it will goes here, right? So because we are using this return keyword, it goes to the called function. Now what is its value? It will be 1. Now here, whether there is any pressing value? No, no, no. So it is returning just a value. So it is what? 1, right? It is what? Just 1. Now what is the value? It also 1. It also 1 because it returns what? Just this value, and we don't have any infront symbols, right? So this returns again. Where it returns? Here. It will returns here. And what is the value of this f of 103? It is what? 1, right? I computed here. So it is 1. Now 1 plus 1. 1 plus 1 means it is 2. Because of this return statement, it will return to the called value. If I called for f of 103, inside this calling value, it will be what? 2. So 2 is my answer. Can you understand now? Yes, yes. Now it's time to discuss what? Time and space complexity. So what is the time complexity? I can say time complexity is O of log n base 10, because we are constantly dividing by what? 10. And what is the space complexity? I can say O of log n base 10, right? So this is our time and space complexity. Let me explain to you here. See here, def extract of num is equal to 0, then return 0. If it is not so, then I have to go and proceed further, like num mod 10 is equal to 0. Then what should I do? 1 plus extract of num divided by 10. I am just breaking out, right? Main problem is like this, and I am checking whether this last is 1 or this last is 0 or anything. If it is 0, I am just pressing 1 and I am just passing the sub problem. That's it. Then return extract of num divided by 10. We don't want to put else, because while seeing this keyword return itself, it will return to the call function. Fine. Then after doing all this stuff, we want to call the function, right? So we are calling like extract of 1, 2, 3, 0, 4. So what will be the answer? It will be 1 when we are executing it. Thank you.